Okay, in this video, we are going to be looking at these things called matrices. We're hopefully just going to go quickly through them, do a crash course pretty much, and my aim is that hopefully you should get a better idea of why matrices are so important and actually where they're used. Okay, because I remember when I first met matrices at A-level further maths, I just learnt the rules. I didn't really have a clue of why I was doing it or why they were useful. I just learnt the rules and I managed to get my way through the exam that way. But actually matrices are incredibly useful. Granted, you don't meet them anywhere else pretty much in your maths course. You only meet them pretty much here. But as soon as you go on to degree and you go on to further maths, higher level maths, then that's when the uses really start to become apparent, because you can basically deal with a huge amount of information all in one go by just inputting them into a matrix. So what is a matrix? Matrices is the plural. What is a matrix? It's just a table of numbers, okay? And those numbers have some meaning or some connection between them. So let's first of all start with the basic operations that you can do, because just like any number, say like if you have the number 5, okay, you can actually represent 5 as a matrix, as a 1 by 1 matrix, okay? Now, when we talk in terms of dimensions of matrices, we always go rows first. And that kind of makes sense, because if you think about when we have graphs and we give a coordinate, we always give the row first, then the column. Okay, so the across first, then the up. So if we have a matrix, so if I have a 1 by 1 matrix, that means it has 1 row, okay, and 1 column. Right, so we can represent any number we like as just a 1 by 1 matrix. And actually, I'm going to come back to that idea, particularly when we're dealing with things like inverses, because I think this is a really neat way of kind of building up some intuition with matrices. Okay, so basically we've established that we can represent a number, single number, as a matrix. So therefore it makes sense that we can also do operations. So I'm talking add, subtract, multiply, etc. Okay, on these matrices, because after all they are just a table of numbers. So we can do operations on numbers, therefore we should be able to do operations on matrices as well. Okay, so first of all let's deal with addition. Let's say we have a matrix 4, 2, 6, 3, 5, 9. Okay, and we want to add that to another matrix. Let's say 3, 12, 4, 7, 16, and 20. Okay, and we just want to add those two things together. And when we do addition, all we do is we just add each element together. So we want to do 4 plus 3, so 4 plus 3 is 7, then 2 plus 12, so that's 14, 6 plus 4, that's 10, 3 plus 7, that's 10, 5 plus 16, that's 21, 9 plus 20, that's 29. You get the idea. So basically we do it element-wise. We add each element, the corresponding element of each matrix together. So fairly obviously, they have to be of the same dimension. So here, this matrix is a 2 by 3 matrix, and this matrix here is also a 2 by 3 matrix. And fairly obviously, we'll also end up with a matrix of exactly the same dimension. Okay, because we're just adding the elements together. We're not adding any more elements, putting any more elements in. We're just adding the elements in together. And likewise, if this was subtract, okay, we will end up with negative numbers, but that doesn't really matter. It's just useful for the demonstration. So 4 minus 3, that's 1. 2 minus 12, that's minus 10. 6 minus 4, that is 2. 3 minus 7, that is minus 4. 5 minus 16, that is minus 11. 9 minus 20, that is minus 11, I think. Okay, you get the idea, basically. It might be, you get the idea. Okay, so we can do addition, we can do subtraction. Let's move on to, let's start with subtraction there. Let's move on to multiplication. So, let's say we have a matrix, 6, 4, 2, 3, 12, 1. Okay, so that is a 2 by 3 matrix. And let's say we want to multiply that by matrix 4, 2, 1, 3, let's say 2, I'm just trying to make this easy for myself, and let's say then 5. Okay, so we've got a 2 by 3 matrix, and we want to multiply that by a 3 by 2 matrix. Now with matrix multiplication, to find out whether we can actually multiply the matrix together, okay, so we have to have, let's say, have an n by m matrix, we want to multiply that by an m by p matrix. Now these, if in order to be able to multiply the matrices together, these two inner numbers, okay, have to match. If they match, great, we can do the multiplication. And then the dimension of the resulting matrix will be given by the outside. So here, it will be an n by p matrix. So we've got here, this is a 2 by 3 matrix. And we want to multiply that by a 3 by 2 matrix. So we can multiply it together because the inner two numbers match. And the resulting matrix will be a 2 by 2 matrix. Okay, so let's test that out. Now remember, when we do matrix multiplication, it's a bit of a weird step, but it kind of makes sense if you think, right, we do rows and columns. We multiply it, so the row of this matrix multiplied by the column of this matrix, okay? And we multiply each element together of the row with the corresponding element in the column. So first element of the first row, multiply the first element of the first column, plus second element of the first row, multiplied by the second element of the first column, plus third element of the first row, multiplied by the third element of the third column. Okay, so watch what I do. So 6 times 4, that is 24, plus, this is all in the first element position, the first top corner, plus 4 times 1, plus 2 times 2. Okay, so that is the element in the top corner. Okay, and then in the second, so the first row, second column, that's going to be the first row of the first matrix multiplied by the second row of the second matrix. So we've got 6 times 2, that is 12, plus 4 times 3, that is 12, plus 2 times 5, that's 10. Okay, and then in this position down here, I should draw the brackets in, maybe that might make a bit more sense. This element down here is the second row, first column. So the second row of the first matrix multiplied by the first column of the second matrix. So it's 3 times 4, which is 12, plus 12 times 1, which is 12, plus 1 times 2, which is 2. Okay? And then the element which goes in here is the second row, second column. So second row of the first matrix multiplied by the second column of the second matrix. So it's 3 times 2, which is 6, plus 12 times 3, which is 36, plus 1 times 5, which is 5. Okay? And so let's just do a little bit of simplification. This is 32, 24, 34, 24, 26. And here we have got, what's that, 47? And there we go. Okay. Now, here's a really important point. Basically, if we now did this in normal multiplication, this is slightly different. It's if we did 3 times 2 in normal multiplication, okay, so the number 3 multiplied by the number 2, not dealing with dimensions here. Number 3 multiplied by number 2, that's obviously 6. Well, that's the same as doing 2 times 3. Okay, so if we flip these numbers around, it doesn't make so much of a difference with multiplication. But with matrix multiplication, it does matter. Okay, because if we now did this multiplied by this, we would get a different answer. And actually, in fact, we would get a different dimension. And it may also not match, because if this number was different, we wouldn't be able to do the matrix multiplication in the first place. Okay, so I'm going to leave it there for now. And then the next video, we're going to be looking at the next step of the next operation, because the next operation that comes next is division, but you'll find out that you can't actually do division of matrices.